Ask 10 different people who train seriously what actually builds muscle, and it's entirely possible to get 10 different answers, each delivered with total confidence, each citing the science as its foundation. One will insist nothing matters more than training to absolute failure, pushing every set until the muscle simply refuses to move. Another will swear by frequency, hitting each muscle group 3 or 4 times a week rather than once. A third will point to protein, certain that without a very specific, very high daily gram target, none of the rest matters at all. What almost none of them mention is that researchers have actually run these variables against each other directly in controlled trials for decades. And when the results from all of that testing are lined up side by side, the variables don't turn out to matter equally. Some of them barely matter at all. One of them, consistently across the widest body of evidence in the entire field, matters more than the rest combined. This isn't a niche academic question. The global fitness and supplement industry is built substantially on the premise that the real answer is still out there, still undiscovered, still available for the right program or the right product to unlock. That premise survives mainly because so much of the public conversation around muscle growth treats every training variable as equally uncertain, equally debated, equally worth arguing about in a comment section. The actual research literature doesn't treat these variables as equally uncertain. Some questions in exercise science have been tested exhaustively enough across enough independent labs and enough total participants that a real hierarchy has emerged, and it looks almost nothing like what dominates typical fitness content. Before ranking anything, it helps to understand what muscle growth mechanically actually requires. Resistance training stimulates hypertrophy primarily by exposing muscle fibers to mechanical tension. A working set performed against real resistance, close enough to a fiber's capacity that it recruits the higher threshold motor units responsible for meaningful growth. Additional factors like metabolic stress and localized muscle damage appear to contribute as secondary signals layered on top of that core mechanical stimulus. In practice, this means the muscle needs to be loaded repeatedly over time in a way that consistently challenges its current capacity. The classic principle of progressive overload. What was much less settled until relatively recently was exactly which knobs, how much, how often, how close to failure, fueled by how much protein, actually move that needle, and by how much. Start with the variable that gets argued about constantly online, proximity to failure. The intuitive belief, repeated in gyms for generations, is that a set doesn't really count unless it's taken all the way to the point where another repetition becomes physically impossible. The idea that maximum effort produces maximum growth and anything short of true failure is somehow leaving gains on the table. This is exactly the kind of claim controlled research is well suited to test, because it's straightforward to design a trial where one group trains sets to complete failure and a matched group stops a rep or two short, with everything else held constant. A 2021 systematic review and meta-analysis, pooling the available controlled comparisons, found what researchers describe as a trivial to small advantage for training to failure over stopping short of it, an effect so modest it barely registered as statistically meaningful. A more recent 2023 meta-analysis, led by researcher Martin Refalo, dug further into the same question and reached a similar conclusion. The pooled effect favoring closer to failure training existed, but the magnitude was small enough that, by the author's own comparison, adding a single additional set to a session tended to move the needle on hypertrophy more than pushing an existing set all the way to failure. A follow-up 8-week trial in already trained lifters, comparing sets taken to true failure against sets stopped 1 to 3 repetitions short, found essentially identical muscle growth between the two approaches, with the group that stopped short reporting meaningfully less accumulated fatigue along the way. Perhaps most telling, a 22 of 24 series of meta-regressions specifically separated the effect of proximity to failure on strength from its effect on hypertrophy, and found the two outcomes respond differently. Strength gains held up across a wide range of how close to failure lifters trained, while hypertrophy showed only a modest and somewhat inconsistent relationship with training closer to the limit. None of this means training to failure is harmful, or that it never has a place in a program. It means a specific belief that failure is a requirement, that a set doesn't count without it, isn't well supported by the accumulated evidence. It's a tool, occasionally useful, not the foundation the mythology built around it suggests. Move to a second widely debated variable: training frequency, meaning how many times per week a given muscle gets trained. For years, plenty of popular programming operated on the assumption that hitting a muscle group only once a week, the classic bodybuilding bro split, left significant growth on the table, and that training each muscle more frequently was inherently superior. Researchers tested this directly too, and the answer that emerged was genuinely surprising to a field that had spent so long treating frequency as its own independent lever. A systematic review and meta-analysis of the frequency literature found that when total weekly training volume was held equal between groups, frequency itself didn't produce a meaningful difference in hypertrophy. Training a muscle once a week with 12 total sets produced results statistically similar to training it 3 times a week with 4 sets each time, as long as the weekly total stayed the same. Frequency only showed an advantage in the subset of comparisons where higher frequency also happened to come with higher total volume, meaning the volume, not the frequency itself, was doing the actual work. Frequency, in other words, turned out to function mainly as scheduling, a way to organize how a given amount of training gets distributed across a week, rather than a growth driver in its own right. That finding quietly redirects the entire investigation toward the variable both of those results kept circling back to without ever naming as the real subject: total weekly training volume, typically measured in working sets per muscle group per week. This is where the evidence base is not just larger, but structured differently. Instead of a simple yes or no comparison, researchers have been able to map an actual dose-response curve, tracking how hypertrophy outcomes change continuously as weekly volume increases. The foundational analysis here, published in 2017 by Brad Schoenfeld and colleagues, pooled 15 controlled trials and found a statistically significant graded relationship. More weekly sets produced more muscle growth, with the effect estimated at roughly 0.33% additional hypertrophy for every additional weekly set across the range of volumes studied. Even relatively low volumes, under 5 sets per muscle per week, produce some growth, particularly in less experienced lifters, but the data consistently favored higher volume approaches, with sets in the 10 to 20 range per muscle per week emerging as a commonly cited evidence-supported target for many trained individuals. A more recent Bayesian meta-regression, published in 2024 and building directly on that earlier work, arrived at a strikingly similar per-set effect size using different statistical methods, a form of independent replication that gives the underlying pattern considerably more weight than either analysis would carry alone. That doesn't mean the relationship climbs forever without limit. A 2022 systematic review specifically investigating the upper end of the volume range found evidence of diminishing returns, and in some trials, reduced hypertrophy at very high weekly volumes, a pattern researchers attribute to accumulated fatigue outrunning the body's capacity to recover and adapt between sessions. The exact shape of that upper curve remains genuinely unsettled in the literature, with relatively few controlled trials pushing volumes high enough to map it precisely. But across the range most lifters actually train in, the core relationship, more sets, more growth, up to a point governed by individual recovery capacity, is among the most consistently replicated findings in the entire hypertrophy literature. And it has survived direct comparison against nearly every other manipulable training variable researchers have tested it alongside. There's a fourth training variable worth examining before leaving the gym floor entirely, because it might be the most deeply held assumption of all: the belief that heavy weights, lifted for low repetitions, are simply necessary for serious muscle growth. That a set of 25 with a light dumbbell can't possibly be doing the same job as a set of 6 with a heavy barbell. A 2017 meta-analysis, again led by Schoenfeld's group, directly compared loads above 60% of a lifter's 1 repetition maximum against loads below that threshold, in every included study taking sets to genuine muscular failure regardless of the weight used. The result contradicted decades of assumed wisdom. No meaningful difference in whole muscle hypertrophy between the heavy and light groups. The effect size difference between conditions came out at just 0.03, statistically indistinguishable from 0. Heavier loads did produce clearly superior gains in maximal strength, an outcome that makes intuitive sense, since strength testing itself rewards familiarity with heavy, low-repetition effort. But for building muscle size specifically, a wide range of loads, provided the set is genuinely challenging, produced remarkably similar results. Follow-up research digging into the underlying physiology found a plausible explanation. When a lighter load is taken all the way to genuine failure, the same higher threshold muscle fibers responsible for growth end up recruited anyway, simply later in the set once fatigue accumulates enough to demand it. The heavy weight isn't required to reach those fibers. Failure, or something close to it, gets there regardless of the number on the bar. Even here, though, the picture isn't perfectly uniform. Some more recent exploratory meta-regression work has suggested a possible modest tendency for lower loads to slightly favor growth in slow-twitch fibers, and heavier loads to slightly favor fast-twitch fibers, a nuance researchers describe as worth watching rather than a settled correction to the core finding. And there's a practical asterisk worth noting for anyone training with very light loads specifically. Pushing a 25 or 30 repetition set genuinely close to failure is, by most lifters' own reporting, considerably more unpleasant and fatiguing than reaching the same relative effort with a heavier load and fewer repetitions. Which is part of why moderate loads in a roughly 6 to 20 repetition range remain a practical default for most programs. Not because the underlying hypertrophy research demands it, but because most people find that range easier to sustain with good form and reasonable discomfort week after week. There's one more piece of this puzzle that sits outside the gym entirely: protein intake, which determines whether the body actually has the raw material available to build the tissue all that training is signaling for. This question has its own extensive research history, culminating in a 2018 meta-analysis and meta-regression led by researcher Robert Morton, pooling 49 randomized trials and more than 1,800 participants, specifically examining protein supplementation alongside resistance trainings. The analysis found a clear, statistically identifiable plateau. Benefits to fat-free mass and strength increased with higher protein intake, up to roughly 1.6 grams per kilogram of body weight per day, and intake beyond that point in the pooled data stopped producing additional measurable gains. The confidence interval around that breakpoint extended up to roughly 2.2 grams per kilogram, which is part of why researchers and coaches working from this data tend to recommend a range rather than a single fixed number, accounting for the real uncertainty in exactly where, for a given individual, the plateau sits. The same analysis found that the benefit of additional protein was somewhat reduced in older adults and enhanced in those with more resistance training experience, adding useful nuance without disturbing the core finding. Past a moderate, achievable threshold, more protein does not appear to translate into more muscle, at least not according to the best pooled evidence currently available. Line all of this up, and the hierarchy the research actually supports looks almost inverted from what dominates casual fitness conversation. The variable most associated online with intensity and effort, training to absolute failure, carries the smallest, least consistent effect of the group, useful in moderation, but far from essential. Frequency, treated for years as its own independent principle, turned out to be mostly a delivery mechanism for volume rather than a growth driver in its own right. The specific weight on the bar, long treated as sacred, turned out to matter far less than which fibers ultimately got recruited by the time a set ended. A question of proximity to fatigue, not the number of plates loaded. Protein matters, clearly and measurably, but only up to a fairly moderate, achievable ceiling, beyond which the evidence doesn't support chasing higher numbers for additional growth. And total weekly training volume, unglamorous, cumulative, entirely a function of consistency over time rather than any single dramatic effort, carries the largest, most repeatedly replicated dose-response signal of any variable researchers have tested, standing up across multiple independent meta-analyses using different statistical approaches and arriving at strikingly similar conclusions. That's not the kind of finding that sells a program because it doesn't point to a discovery. It points to arithmetic. Showing up, doing enough total working sets per muscle group across a week, sustaining that over months and years, while eating enough protein to support the process. A formula built almost entirely out of consistency rather than any single technique, intensity trick, or scheduling hack. None of the four variables examined here work in isolation, and none of them override the others entirely. A lifter who ignores protein won't outtrain that gap no matter how much volume they accumulate, and a lifter who never progressively increases their training stimulus won't keep growing no matter how precisely they hit their protein target. But when researchers have specifically tried to determine which lever moves the outcome furthest, most consistently, across the widest range of independent studies, the answer that keeps emerging isn't about finding the right secret. It's about doing more of the ordinary, correctly, for longer than most people are willing to. Which leaves the original question with an answer that's almost anticlimactic compared to what a title promising the most effective way seems to imply. There isn't a single hidden method the research has been withholding. There's a ranked list of variables, most of which turned out to matter far less than assumed, and one that turned out to matter more than the rest combined. Not because it's exotic, but because it's the variable most directly tied to simply doing the work, set after set, week after week, for as long as someone is willing to keep going.